Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we're going to continue talking about how we can store linked lists in a file, and in the last video we got our code to the point. We had talked about the format of the file is it has a header that starts with a number of elements and then a firstfree, which is keeping track of the first element in the file that is not being used, and then every record after that has basically the next and the previous followed by an A. I'm going to take the same approach here in this video that we did when we talked about doubly linked lists in the book and in our previous videos, and that is that I want to use a sentinel in here. So we're going to write our methods assuming that we have a sentinel, and going along with that. So if we open the file and it was empty, that would have been this situation right here. So I want to do I want to do some things. I want to actually write those values out to the file. I want to write the 0 and the -1, and then I'm going to write two more zeros for our sentinel node, the values of next and prev. I don't have to write out an A. Turns out we'll just skip the appropriate number of bytes, but something that you might note is that because this is doing a fixed record length file, we're going to need these extra fields that we had for our when we did the sequence that was more like an array. So I can go ahead and paste those in here and do some imports. Okay. That makes me happy. Let's go ahead, let's start writing some methods. Length is easy, so I'm going to start with it. We're just going to return the number of elements. Clear. Now, how about we do a plus equals? Okay, so plus equals is supposed to append an element to the end of the list, so we need to kind of figure out where a new element would go, and then write it out with the links that we want to have. So the first thing we have to do is figure out where the new element is. This would be the equivalent when we were been writing a regular linked list. We would have said new node here. In this case, I'm going to write a helper method how about I call it new node, and I want it to return an int to us, and so that's going to be the location in the file for this new node that we're creating. There are two possibilities here. One is that firstfree is less than 0. We started off with a firstfree of -1. Basically that means that there are no free nodes in this file. Every node that is currently in the file has been used, and so in that case the node that we want to add goes at the end, so we're going to wind up returning num-elms, because we have the sentinel taking up spot 0. If the first thing we allocate is going to go at index 1, and so we'll actually want num-elms +1 for this, because when we start off, the sentinel's at 0 and num-elms is 0, and so we're going to put this basically at element 1. What if firstfree is an actual value? Well, first I need to remember that val ret equals firstfree, and that's the value we're going to give back, because that free node is the thing that we're going to use for our new node. But we have to update firstfree. And the value of firstfree, we talked about this earlier, we're just going to store it in the first field of our record. So we're going to read an int off of our random access file, but we need to seek to the right location first. And where do we want to seek to? We want to seek to the location that firstfree is pointing to. So firstfree times, well, however big our record is, which is 2 times 4, that is for the next and the previous, 2 ints, plus record size, or sorry, record length, which is how much space the A is going to take up. So we seek to that location and we read an int, and that becomes our new firstfree. At this point we also need to, because we've changed firstfree, and firstfree is part of our header, we need to make sure that that gets written out. So I'm going to actually, since I've changed it, I'm going to seek to 4 and write the firstfree. We might wind up writing a helper method that actually writes the entire header, both the num-elms and the firstfree. In fact, actually, why don't we go ahead and do that? Private def write header ref.seek to 0. So we jump to the beginning of the file, ref.write int of num-elms, ref.write int of firstfree, and then technically I can call write header here. Okay. So that gives us the ability to grab a node, or at least grab the number, the index that a node would go at. When we are appending to the end, our code, in addition to getting the new node, needs to link things together. So it needs to make the sentinels next point to the new node, and it needs to make the new node's previous point to the sentinel, so the new node's next points to the sentinel, and the sentinel's previous points to the new node. Okay, that's a lot of pointers to set in there, and so I think I would like to write another helper method in here. Private def to write a whole node. I want to be able to give it an index that I'm writing to, a previous, which is an int, and next, which is an int, and the data, which is an A. And so this should be able to do a seek, much like we did here, to the location of that node, except it's not firstfree, it is index, and then write int of prev, write int of next, and writer on ref and data. This is a helpful method when we want to write out an entire node. However, it's also going to be helpful for us to have the ability to access just the previous and the next. Write prev takes an index, which is an int, and a prev, which is an int, and it's just the first 2 lines here. Next. Well, for this we're going to add an additional 4 bytes and write out the next. And then I'm going to make one more to just write the data. Writer of graph and element. And this time it's +8 because we've skipped over the previous and the next. We'll probably write some helper methods for reading as well. So we need to set the values on these things. The new node that we just created, we get to write the entire node. So write node on in. The previous of this is whatever had been the Sentinel's previous. Okay, so I'll put a variable in there. The next for it should be the Sentinel, which is our is located at 0, and the data that we're writing is elem. So how do we get the sense previous? Well, guess what? That is where we're going to have the ability to read things. I'm going to want companions for all 3 of these to read the previous, to read the next, to read the data, and instead of passing in that int, they return it. And last up, read data, returns an A, reader on that random access file. So now we can come back up here, and the Sentinel's previous would be read previous on 0. Now we need to set the Sentinel, and actually, so sentprev equals read prev on 0. I'm going to go ahead and store that in a temporary variable. So now we need to relink our Sentinel and the Sentinel's prev. So write next on the Sentinel's previous to point to the new node, and write prev on the Sentinel also to point to the new node. This is the this and this created our new node and made it point to the locations that we needed. This line has the node that had been the last thing in the list point to this one with its next, and this sets the Sentinel to point backwards to it with its previous, keeping things nice and circular. The code winds up having the same type of feel as what we did with our regular linked list, but of course the way that we're calling these methods is a bit different. So I'm going to close this video here. We spent a lot of time writing these helper methods, and that will help us out as we go to write all of the other methods, and we'll do that in future videos.